There is a planet out there, right now, orbiting the closest star to our sun. A rocky world, roughly the size of Earth, sitting in the zone where liquid water could exist on its surface. Scientists have named it, photographed its star, calculated its orbit, and we will never reach it. Not in your lifetime, not in your children's lifetime, not in the lifetime of anyone alive on Earth today. And the reason why is so staggering, so quietly terrifying, that most people never hear it explained honestly. By the end of this video, you will understand exactly why. And I promise you, it will change how you look at the night sky forever. But before we get there, quick question. Where in the world are you watching this right now? Drop it in the comments. I genuinely want to know. Let us rewind to August 24th, 2016. Scientists at the European Southern Observatory hold a press conference, and they announce something that stops the room cold. A planet orbiting Proxima Centauri, the single closest star to our sun. Not a gas giant drifting in frozen darkness, a rocky world with a mass almost identical to Earth, sitting inside the habitable zone, the region where temperatures are just right for liquid water to pool on a surface. They call it Proxima Centauri b, and the world goes electric. Headlines explode. Scientists cannot contain their excitement because think about what this means. The nearest star to us in all the observable universe just happens to have an Earth-sized planet in exactly the right place. It felt like the cosmos had placed a second Earth at the shortest possible address and left the door open. The light we see when we look at that star left only 4 years ago. 4 years. That sounds close. That sounds like something you could almost touch. And that is exactly where the story turns into something much darker. Because 4 light years is not close. 4 light years is a distance so violent in its scale that our entire history as a species cannot stretch across it. Proxima Centauri sits 4.24 light-years from Earth. That is approximately 25 trillion miles. If you took the fastest spacecraft humanity has ever built, the Parker Solar Probe, which at its peak moves fast enough to cross the continental United States in under 2 seconds, and aimed it directly at Proxima Centauri, the journey would take over 6,000 years. 6,000 years ago, humans had not yet invented the wheel. And that is the fastest we have ever moved anything. The word nearest is doing something dishonest in your brain right now. It is making proximity feel like accessibility. It is not. Nearest only means it is first on a list that contains hundreds of billions of stars. Being first on that list does not mean it is close in any sense that a human being or a human machine can currently use.
Now here is where most videos stop. They give you the big number, they tell you it is far, and they move on. But the real nightmare is not the distance itself. The real nightmare is what solving the distance actually requires. Because there are not 1 or 2 problems standing between us and that planet. There are at least 3 completely separate walls. Each one alone would be a civilization-defining challenge. Together, they form something that looks less like an engineering problem and more like a physical law written specifically to keep us here. Wall number 1, speed. Every method of propulsion humans have ever invented fails at interstellar scales. Chemical rockets, the same technology that carried astronauts to the moon, would need fuel tanks larger than planets to reach even a fraction of the speed needed. The math is brutal, and it does not bend. The rocket equation means every kilogram of fuel you add requires more fuel to move that fuel, which requires more fuel to move that fuel, and the spiral never resolves. Nuclear propulsion offers more promise. Designs from the 1970s, like Project Daedalus, proposed using controlled fusion explosions to accelerate a spacecraft to roughly 12% of the speed of light. At that velocity, the trip to Proxima Centauri takes about 40 years. But here's the catch. Daedalus was never built. Its fuel, a rare isotope called helium-3, barely exists on Earth. The designers proposed mining it from Jupiter, using balloon platforms floating in a gas giant's atmosphere for a fuel source we would need by the millions of tons. And even if you solve all of that, a 40-year flight assumes the ship never needs to stop, which brings us directly to wall number 2,
stopping. This is the problem that quietly destroys most interstellar mission concepts. Getting to 10% of the speed of light costs an extraordinary amount of energy, but stopping from 10% of the speed of light costs almost exactly the same amount of energy all over again. You cannot coast to a halt. There's nothing to coast against. You need to burn your engines in reverse with the same ferocity that got you moving. That means carrying twice the fuel, or finding another way to brake. Magnetic sails have been proposed, using interactions with charged particles to create drag. Photon pressure from the destination star could theoretically push back against a light sail, but Proxima Centauri is a dim red dwarf emitting barely a fraction of a percent of our sun's brightness. For anything larger than a postage stamp, its light pressure is effectively nothing. No deceleration system for a crewed vessel has ever been built. No deceleration system for a crewed vessel has ever been tested. Every mission concept that includes slowing down is built on technology that exists only in papers and simulations. And wall number 3 is the one nobody talks about loudly enough: keeping people alive. A spacecraft large enough to house a crew across 40 years of flight must be a self-contained world. Closed-loop life support that recycles every drop of water, every breath of oxygen, every gram of waste, without a single critical failure for 40 years. The closest attempt at a sealed, self-sustaining ecosystem was Biosphere 2, built in Arizona in the early 1990s, a 3-acre enclosed environment designed to support 8 people completely independently. It failed within months. Oxygen levels crashed, crops failed. The experiment had to be broken open and resupplied from outside. On Earth, with sunlight streaming through the windows and engineers standing by with emergency supplies. Now imagine that problem in a metal container hurtling through interstellar space with no resupply, no rescue, and a communication delay to Earth measured in years. Beyond life support, the radiation environment between stars would deliver a cumulative dose to the crew roughly 40 times the limit NASA sets for an astronaut's entire career. Dense shielding reduces that dose, but it adds hundreds of tons of mass to a ship already straining against the limits of any propulsion concept ever imagined. And every ton of shielding means more fuel. More fuel means more mass means more fuel. The spiral again. There's no clean solution. There is only a series of trade-offs that each make every other problem worse. Here is what I promised you at the beginning. The real reason this is terrifying. Not the distance, not even the engineering. The terrifying part is this. The most ambitious, best-funded attempt to reach Proxima Centauri with even a microscopic robotic probe, not a human mission, a chip the size of a postage stamp on a one-way flyby with no ability to slow down, no life support, no crew, nothing but a camera and a radio. That project raised $100 million, recruited some of the most brilliant scientists on the planet, and ran for nearly a decade. It stalled. After spending less than 5% of its budget, it entered indefinite hold. Not because the idea was wrong, because the engineering reality at every single step came back harder than expected. A gram-scale robot on a one-way flyby. That was the stripped-down minimum possible version of reaching the nearest star, and it proved too difficult to execute within a decade of serious effort. A human mission to Proxima Centauri requires everything that project required, plus a vessel massive enough to support human life, plus radiation shielding, plus closed-loop ecosystems, plus medical facilities, plus propulsion powerful enough to move all of that mass, plus deceleration capability, plus the psychological endurance to keep a community of human beings functional in a sealed container for 40 years with no outside contact, and the mechanical reliability to ensure that nothing fails beyond repair across that entire span. And at the end of all of that effort, all of that expense, all of that sacrifice, the crew arrives at a planet we cannot yet confirm is habitable. Proxima Centauri b might have oceans, it might have an atmosphere thick enough to walk under. Or it might be a scorched, airless rock stripped bare by decades of radiation from a violent, flaring star. We do not know. We cannot know until something gets there. And right now, nothing we have built can get there. Step outside tonight. Look south if you can. Somewhere in that sky is a star too faint to see with your eyes, the closest star in the universe to the one that keeps you alive. It has a world orbiting it, a world the size of yours, and it is so far away that every speed humans have ever achieved, every fuel we have ever burned, every machine we have ever launched falls short of reaching it by a margin so enormous that crossing it may take not decades, not centuries, but a transformation of human civilization so complete that the people who finally make the crossing will look back at us the way we look back at the first humans who learned to make fire. The stars are not hiding. They are simply operating at a scale that does not notice us yet. And the nearest one, the single closest point of light beyond our own sun, is already enough to make everything we have built look like a first step taken at the edge of an ocean with no other shore in sight.